Okay, in this video we're going to talk about converting uh, decimal number to hexadecimal and binary. See, you say like, first of all talk about the decimal, what's the, like 573, okay? This is in the base of 10, the decimals, in the base of 10. What does that mean? Means that this one is 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2. You know, these, as you go to the left, the degree, the exponent is going to add 1. If you had like, you know, another number here, like 9, so then to the power of 3. Now let's, this one is easier to find it. See, the reason is the base of 10 is because 3, let's start from here. 5 times 10 to the power of 2 plus 7, this one, times to the power of 1, and plus 3 times to the power of, these are multiplication, times to the power of 10 to the power of 0. And you know, 5 times 10 to the power of 2, you know, 10 to the power of 2 is 100. It means 10 is going to be multiplied by the number of the exponent. The base, you know, by the number is going to be multiplied by the number of exponents. There are 2 of them, so 10. If it's 10 to the power of 3, then it's going to be 10 times 10 times 10. Okay, now here, 5 to the power of 2 is 100. It's 5 times 100. Okay, this is the multiplication, plus 10 to the power of 1 is 10. Means 10 times 1. Only 1 times is going to be multiplied. The plus 7 times 10 is going to be 70, and plus 10 to the power of 0 is going to be 1. So it's going to be 3 times 1, it's going to be 0. So it's a 500 plus 70 plus 3 is going to 573. So that's the base of, that's base of 10. But if you want to change this, convert it to hexadecimal and binary numbers, you know, what you do, you want to convert it to hexadecimal. This is decimal, decimal, convert to hexadecimal. Okay. So what you're going to do, you divide, you know, hexadecimal, the base is 16. Okay, so you divide 573 divided by 16 is going to be 35.8125. Okay, and then you get the decimal part of it, you know, the remainder, it's going to 0.8125 times 16, and that is going to be 13. So this is going to be 35, the integer part of it, and the remainder are 13. You know, you multiply the remainder by 16, you get 13. Now this is one step, step 1. Step 2. Step 2, you come here to say 35 divided by 16 is going to be 2.1875, and then 0.875 times 16, you are going to get 3. So it's going to be 2 with the remainder, the decimal part of this, multiplied by 16, you get 3. Now, you say that that's the second step. This is the first one, this is the third step. You got 2. 2 divided by 16 is going to be 1.25. 0.125, and then 0.125 times 16 is going to be 2. So this is going to be 0 and R remainder 2. So what you do here is you go this way up. After all those just the remainder. You say 2, 3, 13. You say 2, 3, 13. Okay, in hexadecimal, the thing is you see. Let me tell you something, that in hexadecimal there are 16 numbers. See, it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10, 11, 12, 13, 14, 16. See, from 0 to 9, we use the same thing. But after like 10, we call it A, B, C, D, E, F. 15, I'm sorry. So there are, from 0 to 15, that's the to write it in a decimal, from decimal to hexadecimal, we put here 13 is equal to D. And now we can say 2, 3D. 23D is the equivalent to 573. So to hexadecimal is going to be 23D, which is base of 16. Okay? Now, this is let's talk about just converting converting from you have something like 2F. Okay, you want to convert it. This is hexadecimal. Convert it to decimal. Convert to decimal. What is going to be? See, what you say is this one is 2, okay, and this one actually is 15. Okay. So, in order to find the number here, we say 2. Okay, this is the value of 2. 2 is, this is 16.0. Okay, let me write it this way. 16 to the power of 1. See, the base is 16. So the first one is 16 to the power of 0, which is 1, and 16 to the power of 1 is 16. And this is going to be multiplied by this number, 2 times 16 plus 1 times 15. This is 15. Okay, this is 15. F is equal to 15. So 32 plus 15 is equal to 47. So that's the way, you know, you find this to convert it from hexadecimal to decimal. The decimal point is going to be 47. Okay, or let's like this here, 23D. This is 16 to the power of 0, 16 to the power of 1, 16 to the power of 2. D is equal to 13. So it's going to be 2 times 16 to the power of 2 plus 3 times 16. 16 to the power of 1 is 16. And then plus 13 times 1. See, this one is 16 to the power of 0 is 1. So what you do, you can use calculator to find out 16, it says 16 to the power of 2, 256 times 2, 512 plus 316 is 48 and plus 13. So if you add those, 512 plus 48 plus 13 is equal to 573. So what we did, we said from decimal to hexadecimal, okay, it's going to be 23D in hexadecimal, you know. The characters there, they're 3, 2, 1, 2, 3. 22 is going to be multiplied by the, you know, each of them is 16 to the power of 0. This one is 16, the second one to the left is 16 to the power of 1, and the third one is to the 16 to the power of 3. And then you do this, you see, you will change this one, 22 hexa, this is hexa decimal to decimal, which is 573. We once change it from decimal to hexadecimal, and then from hexadecimal to decimal. So that's one of the things that you should learn how to convert those. And so there are some, if you want to convert, for example, convert a number like 54. 54 in decimal. In decimal, convert it to binary. Okay. See, let's talk about this a little bit. This is very important part of the networking. We are talking about the networking one. You are gonna learn in IT majors. Networking is the first year in college in majoring IT, so you should know about this. See, the binaries is let's start from the binary. The base is the base is 2. Okay, now you see what does that mean? You remember you said 16 to the power of the number 16 to the power of 0, then 16 to the power of 1 for the second number, and then 16 to the power of 2 for the third number. In this one here, change it, to decimal. In binary, like this: 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3, to the power of 4, to the power of 5, to the power of 6, to the power of 7. And what are these? This to the power of 7 is 128. This is 8 bit. This is to the power of 6. It's going to be 92. To the power of 6, I'm sorry, 64. To the power of 5 is 32. To the power of 4 is 16. To the power of 3, 8. To the power of 2, 4. To the power of 1 is 2. And this 1. You know that we already talked about it in earlier, the basics of mathematics. That to the power of 5 is going to be what does y is? This is 2 to the power of 5. 2 to the power of 5 is equal to 32. So what you do, you break it down. 32 divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Divided by 2 is 5. So there are 5 of them. If you multiply these by each other, it's going to be 2. There are 5 of them. 2 to the power is 5. 2 to the power of 5 is equal to 32. So what we do here, we say 50, you have 54. Okay? 54. What we do, we want to write it in binary, 0 and 1, because the computer only understands 0 and 1. And we want to convert it to 0 and 1. So what you do, you say 54 to binary. We start from here. Okay, 64 is larger than 54, so we start from 32. We add some of these together to make 54. So this is going to be 1, 0, 0. This is going to be 1, 32. And then we add 16 is going to be 48. So it's still below that. So this is going to be 1. So is total here is now 48. Okay. 48. 48 up to 54. It's going to be 6 more. We need 6 more to get 54. 6, we can say, hey, this is going to be 0. 4 plus 2, which is 1 here, is going to be 6. So it's 1, 1, 0, 1, 1, 0. So 54 is going to be if you put the 0, that be in 8-bit, if you put the 0, that there is no problem. But you can write it is 1, 1, 0, 1, 1, 0 is equal to, in decimal, is going to be like that. So changing from decimal to binary we go like this. Let's solve some other example. Okay, like 9 from decimal to binary. Okay, from decimal to binary. 9 is going to be what? So we write the same thing. It's 2 to the power of 0, 1, 2, 3, 4, to the power of 5, to the power of 6, to the power of 7, which we know is 128, 64, 32, 16, 8, 4, 2, yeah, 1. Okay, we found 9. 9 with the 16 is larger than 9. No, you know, we go from here to see that we can not write 16 here because 16 is larger than 9. So we 8. 8 is okay. So far 0, 0, 0, 0, 8, 1. Here we got 8 of that of the 9 is going to be left. The leftover is going to be 1. So actually 9 is going to be 1, 0, 0, 1. Because 8, we can only 8 of this is gone. 8 minus 9 is going to be 1 left over. So this is going to be 0, 0, and then 1. 8 plus 1 is going to be 9, which is 1, 0, 0. So these are the things, you know, and if somebody tell you, let's see, we write it to the power of 0 and to the power of, okay, we had 2, 2, 4, 8, 16, 32, 64, 128. These are the to the power of 2, to the power of 4, to the power of 5, to the power of 6, to the power of 7. It's going to be what? 28. You know, you multiply 2 by itself 7 times. You put it in the computer, in the calculator, you know, you find 2 times 2 times 2 times 2 times 2 times 2 times 2, 7, and it's going to be 128. So, if you have something like this, let 1, 0, 0, 1, 0, 0, 0. What is that? So we say we have 16 here, and we have 4 here. There's all zeros. You know. Actually, 1 times 4, 1 times 16, and then add it together. This is 16 plus 4 is equal to 20. So 20 in binary is going to be, in decimal, in binary is going to be 1, 0, 1, 1, 1, 0, 1, 0, 0. This is 20. We have 16. We put 16 on it and 4 left. 4 left, it's going to be, choose this one as 1. 4 plus 16 is going to be 20. So it's going to be 20 decimal to. So there are so one of the things, you know, it's you should remember that like in converting, okay, converting we convert decimal to binary, the decimal to now we convert hexadecimal to binary. Okay. Hexadecimal to binary. What did you do? You know, if you have 14. Okay. You know, we talk about MAC address. There are 6 pair of hexadecimal number like 14, 2F, 37, 1C, 42, and 18. There's 6 of them in MAC address. We'll talk about MAC address and IP address at the next video, but what we're gonna talk about this right now is like if you have 14, you want to convert 14 is hexadecimal to binary. These are in hexadecimal, the 6 pair of these characters that you know that one is 1 here, 4, and F is 15. You know, those are the things about hexadecimal. So if you have 14, what is going to be the binary? See, each of them, you use each of them. See, 1, 2, 4, 8. Okay, 1, 2, 4, 8. See, what you do is first the first one. The first one, what is going to be if you have 1 here? So it's going to be it's going to be 0, 0, 0, 1. This is going to be 14. 0, 0, 0, 1. And then for 1, this is for 1. You know, in hexadecimal 1 here, write it in a binary form, hexadecimal to binary. 1, actually, in the, you write it as a binary, is going to be 0, 0, 1. And 14 is going to be, this is going to be 1 and 4. 4 is going to be 0, 1, 0, 0. So actually it's going to be 2 of these 4 it's going to be this. So these are the units. If you have decimal, you know how to convert it to binary. Hexadecimal to binary, we talked about it, and hexadecimal to decimal, we also talked about it earlier at the beginning of the video, and decimal to hexadecimal. So these are the basics. Then we are going to talk about host and networking, the number of the host and the portion of the you know the address, you know, IP address, that we'll talk about it later. Okay.